All right. Thanks everyone for joining us today for a new series that we are starting on the Hudi community side, which is Lakehouse Chronicle with Apache Hudi. We are super excited to bring this new series to the Hudi open source community. Of course, it has some of the amazing developers and users all over the world. So it's really interesting to bring something that will be more closer to the community and help with more ground level stuff. And I think this could be a good way to learn more about Hudi. So what are we doing with this particular series? Just quickly going over the slide here. All right, so this new series will focus on everything Apache Hudi and how it kind of ties up with the open Lakehouse architecture. So we will have discussion on critical topics, go over architecture internals, do some show and tell, and basically see how to get started with Hudi, how to do things like, how do I run CDC style queries? How does complex concepts like how does concurrency control works in Hudi, right? Or how does Hudi achieve asset-based transactions? So these are some of the important things that we will be going over in this particular series overall with different episodes that we're going to do. And overall, the idea is to make things easier for developers and users to get started and use Hudi in their workload. So irrespective of if you are already an experienced Hudi user or contributor or someone who is completely new to this entire space of Lakehouse, and specifically Apache Hudi, you should be able to find a lot of beneficial content over here, hopefully. And we'll also have a recorded version for each of the sessions. So that way you are free to explore them afterwards, or in case you cannot, join us in one of this live session. So with that, let's move ahead. A little bit of bio, and my name is Dipankar, and I will be your host for most of the times and speaker casually. I will, of course, be joined by other experts in the space, Hudi PMC members, and do some interviews and stuff as well. So lots of interesting things happening in the space. So just keep an eye out. A little bit about me. I'm currently a staff developer advocate at OneHouse.ai. I focus on contributing to open source projects such as Apache Hudi right now, Apache Xtable. I have been in the Lakehouse space pretty much for the last 4 years, working on different table formats, different things. My most recent experience had been with other open source projects in the Lakehouse space, Apache Arrow, of course, and Compute Engine sides, and Apache Iceberg as the most recent one as well. So with that, today we'll explore our very first topic, which is getting started with Apache Hudi and understanding the basics of the table format. And I'll be your speaker for this. I'll walk you through some of the nuances that you might find interesting to understand more from a practical side of view. Most importantly, what we're going to target today is basically I want to show how do we see a Hudi table in action, basically how the file structure is, some of the critical concepts in Hudi as well, right? So the agenda is we'll start with a little bit of premise, which is why or how Hudi even started at Uber. That's how Hudi started. And then we will understand Lakehouse at a very high level quickly, and explore some of the critical concepts in Hudi, like I said, like timeline, file layout, table types. And finally end up with some more practical exploration. So we'll use our documentation, which I'll walk through in a couple of minutes. And we'll use Spark SQL as a compute engine because Hudi is it's a Lakehouse platform, but with the table format itself, you need a compute engine to run Hudi on. So Spark will be our choice of engine here today. So let's take a step back to understand how Hudi started, right? Because the problems that were seen at Uber back then, when Uber was in a hypergrowth mode, they were moving from data warehouse to a data lake. And the problem was whether you have cloud object storage, like a S3 bucket, or on-premise system like Hadoop file system, which is what Uber had at that point of time. It's an immutable storage system, right? So you basically had to put a database layer or a transaction layer on top of the data lake to work with. So that's basically how Hudi started. And the problems, in terms of problem, right, that Uber kind of specifically ran into was with their trips database. That is kind of like a repository for everything around the trips. So like everyone else at the time, they were doing bulk uploads. The process took up to 120 terabytes of data every 8 hours. Which could be pretty expensive. And on top of that, they used to do a full recomputation of all the downstream table again. So that way, it's it takes a lot of time. The end-to-end data freshness would be around 24 hours. So it was bad. So they noticed their ingest performance was kind of really bad with a lot of unnecessary reading, writing, and I/O and compute spend. with no guarantees that the job would finish successfully, right? Because there was no such things like ACID guarantees. No way to concurrency, do some concurrency control, right? If two writers are writing at the same time, how do we handle that? And most of the time we have seen in previous environment that it ends up with like partial writes and wrong data and those kind of things. So this was the basis of kind of how Hudi started at Uber, right? And of course, like sometimes one important aspect to take it from here, and we're going to like dive a bit more into that, is that the goals itself are not specific to just building a metadata layer at Uber, but it started with the whole range of database problem, right? Things like updates, incremental processing, those kind of things. So when Uber started to tackle this problem, they realized they weren't facing a completely new problem. Of course, pretty much all of the database system dealt with this kind of challenges. It is just that they needed to figure out a way to implement these in a way that would fit the architecture of the data lakes, right? So essentially what they decided was, if they could build a system that could be capable of handling updates, deletes, upserts, so you can absorb these changes faster into the table, right? And while we're able to do things like faster updates, can we query a snapshot consistently, right? So by that, we mean that we want to see the version of data that is the right one. So no dirty data, and see things are either committed atomically or not. Plus, obviously, the ability to do things like time travel and look back at a particular point in time, and do things like rollback as required, depending on the scenarios and situations. Also, it wasn't just the ingestion problem, though, right? Obviously, ingestion was the main problem, but there was also the need to incrementalize the downstream ETL. For instance, we talked a little bit about the 120 terabytes of data that they consume, and does that every 8 hours. So instead, can we consume only the changes that has happened to the base table, right? Instead of full recomputation. And that led them to build the incremental changes, which is very core to Hudi. And of course, it separates from other table formats like Iceberg and Delta. And again, while all these reads and writes are going on, there is also the need to manage the data optimally, right? Pretty much like a database, right? Where you have an internal kind of database process that runs around and does things like clustering, compaction, cleaning. So all this data management capabilities. So all of these principles, these primitives, they led to the formation of Hudi and focus on things like upserts, incremental querying, and snapshot isolation. So moving on, we have come a long way from those beginnings. Started as like kind of transactional layer for the data lakes to what we have seen now, and how it kind of serves as a foundation for the Lakehouse architecture as a platform with Hudi. So what's a Lakehouse? People might be already aware, but for people who are just trying to learn a little bit more about it, the canonical jargon is that it's a combination of a data lake and a warehouse architecture. But of course, it's not just a mere combination of the two, but the whole idea is basically to take best of both worlds. Okay. So for instance, data warehouses, they are great with data management and optimization capabilities, like things like compaction, clustering, ACID-based transaction, and the ability to do things like time travel, schema evolution, like all those operations like transaction, like upserts, deletes with ACID guarantees. And on the other side of the spectrum, the data lake architecture came mostly to target the cost factor. Of course, data warehouses were super costly, and it provides it has scalable. It's very much scalable. You can scale infinitely as you want to with this kind of object stores like S3, Azure Blob, Google Cloud. But most importantly, cost-wise, these object stores were very cheaper, right? Which is really great for from a customer point of view. So a lakehouse basically builds on this idea, and one of the core ingredient in a lakehouse is, of course, like the the transactional layer that you see here and the dotted boxes. I'm going to talk a little bit about the formats and this kind of overall component itself. So we'll start from the bottom. So if you see in the bottommost part, you see the lake storage, and this is where your data lands after ingestion from operational system. Like I said, this could be any kind of file system, whether it's your Amazon S3 bucket, whether it's your local file system, whether it's Hadoop file system, whatever it is. You are going to use this as a storage for your Lakehouse architecture. And a layer on top of that is basically the file format. And this is where you write your actual data, right? The bytes are written into the file format, this immutable file. Usually in columnar format, of course, there is an advantage in terms of like reading, from columnar formats that provides the advantages. And analytical workloads are also very much read heavy. So that is amazing. And on top of this file format, there you see this kind of like transactional database layer of Hudi, and in any kind of table format for that matter. But what kind of separates Hudi from the, what kind of like brings out the main like kind of capabilities of Hudi is that it offers this different kind of services, right? The table management services like concurrency, the compaction, the clustering, ability to like clean the tables that are not required, the files that are not required, and of course other things like transactions, snapshot isolation, concurrency control. These are super critical, and that is what actually makes the data lakehouse architecture more robust. So Hudi comes with this entire stack and platform, of course, starting from ingestion. But one important thing to note here overall in this lakehouse architecture is the storage layer, which basically consists of the table format, the open format that you see here, and the file format, right? So the important thing here, as if you compare to like a data warehouse architecture, which also provides these transactional guarantees, is that this storage layer, which is the file format and the table format, they are stored openly. That means it's open to any compute engine. The APIs itself are open to any compute engine as they would like to consume. So unlike a traditional data warehouse where you are pretty much locked into their own storage, into their own proprietary file and table format, this is a bit different, and that's what enables kind of an open lakehouse architecture overall. All right, so until this point, we have a fair understanding of a lakehouse architecture and how kind of Hudi fits into that model with the table format plus the transactional database layer, all those things around that. Now let's zoom into more of the technical aspects of Hudi and all those core concepts that we were talking about, right? And we're going to see obviously like some of those things in action, more of a practical exploration. So starting with the Hudi timeline, right? This is basically the backbone of Apache Hudi. The timeline, it enables ACID transaction. It powers some of the critical capabilities to efficiently handle transaction in data lakes. So essentially, it is a type of an event log that captures every change to a particular data set or table, right? Including all the operations that has run, like insert, update, deletes, and the different table management services like compaction, cleanup, restorations, and those kind of things. So what is important to understand here is this timeline, it consists of a series of instants, okay? And I'm going to break down what is an instant here. So an instant is basically, it represents an event that occurred on that particular data set or the table, right? So things like commit, compaction, we talked about. And you can see the diagram a little bit more here. If you consider the dotted arrow as the timeline, all these different like data points that you see here are basically different instants on the timeline, okay? And each instant on the timeline is basically characterized by three components. One is the instant action, which is what is the type of action being performed on the instant, whether it's a commit, whether it's a rollback, whether it's a delta commit. Next is the instant time itself, which is at what timestamp do we particularly do that particular action, right? And this is super important, of course, for kind of coordinating this transaction and maintaining this kind of guarantees. And the third part is the instant state, which is basically what is the current state of the instant. And this can be like three types, whether it's in flight, requested, or committed. And we can see, let's take a data point over here, right, which is a particular instant over this, okay? So this instant is the action is commit. So that means some kind of commit action happened here, some kind of write operations, maybe some kind of insert updates. And the state is completed. Of course, that means the operation is completed and the timestamp itself is noted over here. So these three aspects basically makes up a particular instant. And Hudi tracks everything on the timeline and keeps the track of all this that's happening in the timeline. So that's basically the core thing to understand over here. So if you think from more of a practical exploration perspective, you are running Hudi in production or that kind of workloads, and you want to understand like something is failing or something is happening on the back end that you are trying to understand that is not as per your expectations. Typically, timeline is what would give you that idea of what has been happening. It kind of is an event log, like I said. So that's important to understand. Moving on, let's focus on another critical aspect of Hudi table. And this is primarily how I kind of started the premise with for today's episode is basically how do I show the Hudi table format. We talk a lot about the table format itself or the Lakehouse architecture itself, but how it kind of translates into the actual technical aspects of it, right? That's super important to understand. So what I want to basically show today is this image that you see here, how it like looks like on your file system that we are going to see based on some of the operations that we are going to run today. So Hudi organizes, and obviously like, there are certain aspects towards it, like we are going to cover all of this. So the first thing is that Hudi organizes into two type of files. One is the data files itself, and one is the metadata file itself. And these are different directories you will see in the file system. So the data file, as you can guess, they are the actual records, right, that are stored in the table, and they are a bunch of Parquet files that store the record. But then there are also the metadata folder, and these consist of the metadata information like schema-related information, history of changes, commits, and all those things that are happening there. Information about indexes is a separate thing in itself, and hopefully we'll have a separate episode in indexes itself. But it's super important to keep a track of those as well. So if you look at the diagram in the left-hand side, you will see two major directories. One is the data directory, which I've highlighted here, and the other is the metadata directory. So this is how actually in the physical storage, like your S3 bucket or any kind of local storage system or Hadoop file system, you will see a Hudi table as. So let's understand the data files part. That's the first thing. So, and then we'll go switch our gear to the metadata part. So under the data part, there are two types of data files. One is the base file, and the other is the log file. So the base file, basically they store the core record of the data set. Basically they're storing whatever record you're trying to, let's say, insert a few record into the table. The base file, the Parquet file, the base file is going to store those record. And since we are using Parquet here, they're optimized for read, things like compression. You can use Parquet's own like footers and internal statistics to, prune some of the query. So that's amazing. And the log file are basically incremental changes to the base file. So let's say you made some insertions and then you want to update a few record. So the log file are basically used to keep a track of that. But the most important thing to consider here or take a note of is log file only comes into the picture when it's a merge on read table. So we are going to discuss these two different table types. One is a copy and write, one is a merge on read. These are different table types as part of the Hudi table. And we're going to see the differences in a while, but basically you have to understand that copy on write table doesn't consist of the log file. It creates new version of the base file itself, whereas the merge on read keeps the track of the log, the changes as a log file. Okay. So this is what we are going to see in our in a few minutes when we explore things on our file system. But overall, this is how the entire file system looks like on your storage. So going a little bit more into how the Hudi's table structure looks like in the file storage system, like I said, overall, we're talking about the data files itself now, right? So we are talking about the data layer, which is where the actual records are being stored, and how Hudi organizes that. That is what we are trying to understand a little bit from here. So overall, if you have a Hudi table, how it translates technically is basically Hudi tables are divided into partitions. So partitioning strategy is one of the most common strategy. It's basically used to optimize the data access and improve query performance by limiting the scope of the data scan. So you only look for the files that are present in a particular partition, right? So that's how you kind of prune those unrelated files. And that is how basically Hudi starts with. It starts with dividing the table into partition. Within each partition, you will see something called file groups and file slices. So file groups and file slices are mostly logical concepts, and you cannot see them physically on the storage. But of course, you can see the partition on the storage because it's a physical concept. And this is basically how we kind of make that distinction between the logical and the physical way of operating on this different file system, right, with this table format. So file group within each partition, you have the partition. Within each partition, the file group are organized into various file slices. And each of these file slices, they will comprise of a base file, as you can see in this diagram here, in a file slice 1, file slice 2, within the particular file group. And with the particular file slice 1, you see a base file, which is the Parquet file. And then you see a log file, given that it's a merge on read table maybe. So that's how basically a file size together combines to. So a file slice will usually comprises of the base file and log file, depending on the table type. So overall, this is how the entire structure look like. You start with the Hudi table. Then you get the partitions, you make file groups, file slices, and finally the file slices will have the base and the log file. All right, so now we know and understand a little bit of the data files and how the overall structure look like. Now let's go to the second part, which is the metadata layer itself and the metadata files. So like I said in the Lakehouse slide before, Lakehouse table format, they are basically a metadata layers. They're sitting on top of the data file. If you consider just the table format part, right, they're just metadata. And what it does, it abstracts the physical complexity of the data structure. So users don't have to deal with those, bytes and files, right? That's kind of the abstraction. So this is exactly what Hudi's metadata layer looks like. So basically, all the metadata is basically combined into a directory and structured directory form, like which is under that .hudi folder, as you can see the start of the image with, like that's the kind of parent directory. And within that .hudi folder, you'll see something like a Hudi property file, which is super important. It contains information about the table, the version of the table, other parameters needed for reading and writing, and that's super important. So we will just explore the properties file in a while as well. Alongside this property file, you will see a lot of this meta log file, which is basically the instant that we talked about in the timeline, right? That is how the timeline is kind of managed, and Hudi is keeping a track of what is happening, what operations are running, if there is any table maintenance operation running, and all those kind of things. And if you like kind of zoom up, this is from a particular exact file that I had in one of my system, is basically, just to show an idea, this is the timestamp. This is the particular action, which is delta commit in this case. And if you see the state, it's in flight. So this is a particular instant that you have on a particular timeline. In addition to this transaction log, the Hudi metadata, there is also a folder called Hudi metadata folder, just a metadata folder, which is again super important. It's a Hudi's internal metadata table. You might have seen some of the database system in the past, which internally is also like a database as well. The whole idea, and we're not going to talk in depth today about the metadata table, because this itself is it deserves a new episode in itself. But basically what it does, it kind of keeps a track of all the indexes. It's kind of a subsystem in itself, and it helps with like optimization and pruning and those kind of stuff. So now let's quickly touch upon our table types, which is what we have been talking about a little bit, and kind of how Hudi handles this different type of updates and operations. So the first table type is copy on write. The name suggests a few things. It's called copy on write. So that means we are going to copy the version of the file during our write, right? So if we try to understand the problem statement, it is basically, okay, we have a table, which, it's a bunch of Parquet file, and let's say a few records have changed. So what are the different ways to deal with that, right? How do we deal with that? So how copy on write and merge on write deals is a little bit different, but overall the idea is kind of the same, right? How do we handle that? So file slices in copy on write table only contain the base columnar file. We talked about it, right? Only the Parquet file. There is no log file in a copy on write table. And every time you commit new data, Hudi will create a copy and produce a new version of the base file. And in the diagram you can see we started with like commit time 0. That means at the first time we commit, it's blue. Then the version has been changing. So that means these are newer versions of the base file of the Parquet file itself. So just take an example here. Let's say you insert records A, B, C, D, E, and Hudi organizes into 3 Parquet file, like Parquet file 1, 2, and 3, right? The blue one on the first commit. And Hudi provides different query type, of course. Here, snapshot query is something very important, because we want to get the latest snapshot of data, the latest version of data. That's something that you would always want to run depending on your workloads. And the second part is the incremental query, where you only see new data written to the table, right? And we talked a little bit about it as well, because we talked about how Uber is to take time, by doing a lot of recomputation of the full tables, which is not really necessary. You can just incrementally process the change and do that kind of processing. So in this case, if you do a snapshot query, because we inserted the record A, B, C, D, E, and they were in 3 different Parquet file, the snapshot query in this particular version will fetch all the record, because that's the first time you committed. Similarly, incremental query also will fetch the same record, because this is the first time we are committing. There has been no change, so there's been no increments, and that's why you see the same kind of records here. But if you go to commit time 1, where you're changing A to A prime and D to D prime, Hudi actually creates a copy of the base file, right? And you can see the copy has been created for file 1 and file 2 in the orange section, but not for the file 3 in the E one, because we aren't touching the E record at all. So that file doesn't get rewritten, right? So in this case, if you run a snapshot query, you will get the updated version, which is A prime, B, C, D prime, and E, because the records have changed and we are just querying the latest snapshot of the data. But if you just query the incremental query, you will just get A prime and D prime, because that is the only change that has happened in this particular commit. So one thing that you might have kind of figured out is that copy on write has a much higher write amplification, whereas on the read side, the amplification is 0, right? And this is much kind of a desired property for analytical workload, which is predominantly read heavy, like I said. Okay, now let's go to our merge on read table, which is another type of table as part of Hudi, and it is actually more flexible, but of course has more operational thing that needs to be done. But everything is same as the copy and write table that we saw until that first insert. things change when we update a file. That's how the strategy is. So let's say in this case, if we update A to A prime, we don't rewrite the entire Parquet file like we did with the copy and write. Okay. Usually for most of the scenarios, you could be just updating one column. In such cases, you don't need to, don't want to rewrite the whole file over and over. It's kind of like expensive as well. So what we do in Hudi is basically we store the incoming updates into a log file. Okay, it's a row-based formatted file, so that means it's really good for append-only kind of updates. And eventually, what we do is by applying a compaction process, Hudi merges the base Parquet file along with the log file and produces a new version of the base file. So if we have to break it down, the file slices in merge on read table consists of both the base columnar file and the log file. Okay, and in the copy and write, it's just the base file, the Parquet file. So when we do a snapshot query, it will basically merge the base and the log file on the fly and return this result. So with merge on read, there are also a different way of querying. For example, we have something called the read optimized query type, which allows you to choose query performance over the freshness of data. So with the read optimized query, basically you can just decide not to merge that particular compaction thing. You can decide not to have that compaction process run underneath and fetch only the data that is present in the base file. So that way you're performing your preference is kind of query performance over the freshness of data. So same thing here, you run an incremental query like snapshot query, incremental query. It's the same thing. At commit time 1, it changes with only the snapshot query giving us the updated one. The incremental query gives us only the change record and so on. All right. So that's with the conceptual stuff and the stuff that you need to get started, with Hudi. Now let's change a little bit of gear here and focus on the practical aspects of getting started with Hudi. So like I said, Hudi is a storage format, the table format itself. So you will need a compute engine to work with it because, of course, that's how you will need to process your data. And the technical way to understand this is that the Hudi provides compute engines a set of standardized read and write APIs, and the compute engine will use those APIs to do all those operations. All right, so I'm going to change a little bit of like the presentation over here and go to our official documentation, which is basically kind of a one-stop destination for everything around Apache Hudi. It has the documentation itself, the APIs, various learn guides, the community aspects, the blogs that we kind of regularly publish over here, and all this kind of different things. All right, so what we are going to do is we are going to take our Spark Quick Start guide and we are going to walk through some of the steps that are here exactly same as it is, and we are going to see how it kind of translates into the file system. In this case, I'm going to use my local file system. So that means I need to have Spark installed locally. So that's the only prerequisite. Basically, you need to run all of these queries that you will see over here. And it's super simple to run some kind of SQL queries using Spark SQL. All right. So let's get started. So the first thing that I want to do here, of course, we want to configure things, Hudi and Spark SQL configuration. That's what is super important. So in my case, I already have Spark in my, like I said, I already have Spark installed in my system locally. I have Spark 3.4. So depending on the version, you can feel free to use your own configuration. So I'm going to take this particular part over here and just put it over in my terminal over here. And like I said, my storage is my local file system. This is what my file system looks like right now. This is my warehouse or your storage. This is where I have different tables in Hudi, and this is where I'm going to show you how this new table is created, how the file structure looks like, how the metadata look like, the data itself, and all those things. So I hope this is going to be more of an exciting and practical exploration. So let's get started. So let's start with the configuration itself, and this is what basically we are downloading the jars required, all the necessary configurations that we want Hudi and Spark to talk with. Hopefully this will give us our Spark SQL interface. Okay, perfect. So we are in the Spark SQL interface now. So that means, and of course, you are not limited to just Spark SQL. We also have the Python-based APIs. So if you're working with Python or Scala or something like that, feel free to work on that as well. So this example should work as it is in here. All right, so the first thing for us to do is start creating our table, which we'll use a simple create table statement. We are going to provide some of the schema information, and we're going to partition this table by a particular city. Okay, so let's do that. I'm going to say a create table Hudi live. Let me come here. All right, so I just pasted the command over here, and if I go and see, this is the time taken, so that means the table has been created. This is the location where I have my warehouse, destination over here, and I can see my new table Hudi live over here created as a new directory, right? So we are going to explore inside of this directory right now. As you can see, it's just a folder which says .hudi, right? We learned a little bit about this. If I have to go back to the slide itself, we saw that the .hudi folder is basically our this is the .hudi folder, right? We talked about the metadata directory here, and this is where our .hudi folder comes here. And inside this, we will, of course, have a lot of metadata related information. We are not going to see that right away. We're going to first start with the data part and then see the metadata part. So, can you guess why there is no data files here? Like, why do we not see the partitions and why do we not see a data file here? Well, the reason is that we haven't started writing any data yet, right? We just created a table. We haven't inserted anything, so that's why we just see the metadata over here until now. Now let's go and insert some data, and we're going to do exact this particular query. So I'm going to insert this particular records over into this table. All right. And while I do that, I'm also going to pull up my warehouse and see if I see the partition created and how the Hudi folder structure looks like. All right. So Hudi is doing its magic underneath and creating the table, and hopefully we'll be able to see the data folder over here as partition, different type of partitions. Perfect. So the command is almost done. It's almost done writing the files, and you can see the different partitions over here. We partitioned with city over here, so that's the first thing that we started with. So a Hudi table overall, this is the table we started with. Then we have the metadata, we have the data files, which is just a partition. So going from the partition itself, we started with this overall idea of like having everything divided into the physical part as partition. So this is what we kind of see over here, right? And inside this partition, of course, the file group and the file slice are logical grouping that I said, and that's how Hudi manages internally. But we're going to explore more of this internal things. All right. So I think the first thing that that would be interesting to see here is basically if I go to a particular partition over here, I can see the actual Parquet file that was being written over here, right? And I just opened up a Parquet viewer over online over here as well, just to show you that what we inserted was basically over here. So I just loaded the Parquet file, and as you can see, this is for that particular partition only though. So you can see, the different Hudi specific like meta fields, like the commit time, the sequence number, and this is all that is internally used by Hudi, to keep a track of all the files and stuff. So that you see the timestamp, all this different details that we wrote and inserted into the table, right? So that is all over here. So that is what we kind of see inside the Parquet file, and that is what is actually written into the folder. Similarly, for other partition, you can see other Parquet file over here. Just another one, just to show a different partition. Yeah, you can see a different San Francisco partition now, and different table, different records over here as well. All right. So this is what we have now. If you see the partitions here, different data files over that, and this is what we have as a base file. Remember, by default, when we haven't inserted, when we even specified anything over here, by default, Hudi creates a copy on write table. So what we are dealing with right now is just a copy on write table. That's why you don't see any log file or any kind of changes in that. Okay. Going to our next part is basically, let's see if we have anything else in this directory. Okay, nothing in particular. Now what we're going to do is we're going to just run a simple query, like a select query, just to show you that records that are already pulled up so that there is no problem. Perfect. So we can see, some of the records that are being pulled up, in the SQL form, super easy to understand. And, that's what we have got it from, depending on a particular filter over here. All right. So moving on, I want to run a few kind of update, right, type of statement just to see how the data files are handling in copy on write, because we talked a little bit about the copy on write table format, right? And how it creates a new version of the base file every time we make a change on this record. So with that, I'm not going to run the update one, but feel free to follow this as well. But I'm going to run something like absurd, which is basically you're just doing a merge into. So for a merge into, the idea is that you basically have a base table, a source table, and use that table as a source and use some of the conditions to match some of the filters, and then you update your main table based on that. So in this case, it requires you to create a fare adjustment table. If you go to my warehouse, I already have a fare adjustment table in here. This is what you see. So I'm going to use this table as my source, and then I'm going to upsert and write into this new Hudi live table. Okay. So I'm going to copy this part because I already have done this part. But when you're running this yourself, you might have to create this table itself. So let's go ahead and run this particular command. But also at the same time, we are going to see, a little bit more about how a particular let's say a particular partition is impacted or not, depending on the records there in the particular files. All right. So as we run this particular table, a particular command, you can see a new Parquet file now it's being written. That's what is happening. So that means there were records that were part of this particular partition, particular file that were being touched, and copy on write made an update of that particular Parquet version. So now we see a new Parquet version which made those updates. Okay. So this completed, and now if we see this our Parquet data, when we started with like this particular one, for example, right? So that's what we started with. I'm going to show a little bit of differences over here. So we started with these two records, and we had some kind of like changes over here, driver S and driver T. But now if we go to the new Parquet file, which is just, this is actually the older one. So you can see, driver S and driver T with some kind of fare. But this was the latest one. So if we go to the latest one, which is at 1238, you can see this fare value have updated. So that means our records have changed overall. So that was basically what I was trying to make a point with like copy on write table, that it kind of rewrites the version of table. This is good for like read side because it's less on the read amplification, but it's also like more on the write side. So it's kind of write heavy in a way. Going back to our guide itself, we did some merge. I'm not going to delete right now, but feel free to use it. They're coming back to a different type of query type itself. There are different types of query that Hudi provides. We talked about snapshot query, any kind of like, query that we talked about. The time travel query is super important because, of course, we want to be able to go at a particular point in time and then be able to fetch certain record on that. Okay. So we're going to see a little bit about how to run a timetable command. It's a time travel based command. It's relatively simple. I'm going to use a different timestamp here, depending on a particular one. I'm going to just select something random over here. Let's say this one. So if I add this particular timestamp over here, I should see some record over here. All right. I think there are no record. I'll just avoid the filter and see if there is any record now. Okay, yeah, we can see a lot of record at this particular timestamp. So, based on a particular timestamp, now I'm getting the record. So, this is super important, right? We want to do some kind of end of quarter analysis, end of financial year analysis, and you want to go back in a particular point in time and you want to only work on that particular set of record. So this is where this comes into like, practice. Other than time travel, we talked a little bit about the incremental query part where we kind of get only the change data. So the way to use it is basically, I use this particular syntax, which is Hudi table changes method, and you can specify your table name. You can specify all the states. For example, like this is the most simplest form, right? You start from your earliest available state, commit, and then you go to the latest state and find all of your changes, right? But also at the same time, you can specify something like, a timestamp and, start and end at a particular timestamp. So I'm going to quickly, show a particular incremental query. It's a basic one again, but hopefully this should pull up some of the record as well. I think you don't need the DB part over here. You can just specify the table name. So using this particular method, Hudi table changes, and by specifying my commit time, which is the earliest to the latest, I was able to get all my records that have been changed in this particular period of time. That is what the incremental query does. Now, change data capture query. Change data capture itself is a topic in itself that requires maybe it would be great to see another example, another episode where we kind of do more of a CDC style query from a database in the real world. But basically, you need to create a table with some parameter, which basically would look something like this. Like you have to basically enable something like hudi.table.cdc enable true, and then you can start writing your CDC-based queries, right? And CDC-based queries are super important for like real-world use cases. Like, for example, like let's say you are an e-commerce vendor and you want to keep a track of whatever is changing in an operational database, in your data lake environment and in real time, that's what you want to like take advantage of CDC. So the table type we saw about is by default. Obviously, we created a copy and write table, but then there is the merge on read table as well. How you can create a merge on read table is something by using type here. It's just a simple property in the table, and you have to just specify that. I'm not going to create this table, but I already have a merge on read table over here, and you can see the different metadata and the folders over here. So the one difference to see over here, because we have been talking about the log files and the base files in the copy and write and the merge on read format, is that in the merge on read format, you can see the main base file, which is a file slice, the Parquet file, but you also see a log file over here, right, which is this particular log file. And this log file is basically what is holding all the changes that were made to this particular data set. That this is log file that you see over here. So that is holding all the changes to that particular set of records. Instead of rewriting a new version of this Parquet, we are appending all of these changes over in the log file. So that is what the merge on read table looks like. So there are some other examples to follow over here, which I would highly recommend. It basically, how to like define some like primary key in Hudi, which is super important, and ordering fields, and that's how basically you can start like building your more like real world pipelines as well. All right, so we went through a little bit about the exploration on the the physical side and how things look like inside the data files itself, the partition itself, and how we understood and related to the overall like the structure that we just started in our slides. Now let's look into the metadata folder, which is our Hudi folder, and it has a bunch of other information as well. So starting with the Hudi folder, you can see the directory looks like this, right? I'm going to go a bit more inside, and I can see various kind of like files here and information here. The first thing that I would like to explore is the properties file itself, and I mentioned about this when we started the discussion. I'm going to bring this text file editor over here. So this is what the entire property file looks like, and what it kind of holds right now is basically things like the table type, right? The properties of the table, like the copy and write. This is a copy and write table, so it has the table type, the version, timeline layout version, whether it's using some kind of a key generator, what is the table name, the different partitioning strategy, right, and the schema itself, like the different schema and the fields that we have in a table. All of these is captured in the properties file, and you can see that in the properties file. So going from the properties file itself, we have the different instant over here. And this is the same instant we are talking about here, right? This is the instant on the timeline. So if you consider this entire thing as a timeline, these are the various instant that is happening over here, right? For example, this particular instant, let's say this is a particular timestamp. This is the action which is committed. And you see requested as basically the state it was in. And also you see other status and other like, actions and all those kind of things. So these are the different instances that we talked about. On top of these, you also would see the metadata folder, and this is what we're talking about with the metadata folder in itself, which we aren't going into this particular discussion, but the metadata folder, it kind of is additional metadata and holds information on indexes and stuff. But what I would like to show you here inside this metadata folder is internally, this is a Hudi table as well, okay? We are trying to take advantage of some of the benefits of Hudi merge on read table over here. So this is what we have right now. And inside the files, these are different types of indexes and systems that you would have. This is what the files in kind of, it consists of the column level statistics in a H file format that uses kind of key point lookups, key value lookups. And this is used to basically prune your data, because instead of looking into each and every Parquet file for, finding out which one satisfies my particular query, you can basically use this kind of different indexes or different kind of like file pruning statistics to basically prune your query and basically get all the files that are related to this. So opening each and every Parquet file and reading and closing the footer, that takes a lot of time, and in scale it can be a lot. Whereas you can just come into this particular consolidated location and Hudi can just find out all the files that are there. So which is comparatively less expensive and increase the performance overall. So this is something that we're going to talk in one of our later episodes, but this is something important to take a note about as well. All right, so that is basically what the entire architecture looks like in terms of we went over like the data files itself. We saw how the partitions are being held, how the data file itself are being organized over here, and the different type of like table types, different metadata types, and all those kind of information over here. That is all I had in this particular session. Quickly, the community part is super important. Of course, this is not possible without the community. Hudi is open source community, and it's amazing to see this diverse set of contributors come and work towards this common goal. So join us on our Slack, join us on our LinkedIn channels, on our Twitter channels. This is a QR code for you to scan in case you're looking for something to join our particular environment and talk to our PMC members. So feel free to give us a shout out or send us a message about any questions that you have around this. That basically ends my presentation around this particular episode 1. This has been a fun one, and going through some of the practical exploration particularly has been super interesting to find out. As a next step from here, I would definitely suggest exploring some of the more deeper concepts by going through our documentation. It's a very well divided section. You can go to the design and concepts under the Hudi stack. You can see the Hudi's overall stack, the timeline things that we all talked about, how the timeline works, the file layout itself. So these are really divided over here, and it can be a good segue into overall Apache Hudi. That's overall my time. So if anyone has any question, I can take over here, or I can take it up later as it comes up. Thank you so much. All right, let's see if I can see some of the questions over here, if there's anything that anyone has to say. Pawan says, thanks. Thank you so much for joining the session, Pawan, and hopefully this was helpful from your side. All right, I can basically give a minute or so to see if there are any more questions around this. So one question that I see is from Humaid, who says, how is Hudi optimized for real-time streaming workloads? Yeah, that's a great question. Yeah, I think the premise that we kind of start with is basically Hudi's overall internal dynamics and how the design principles are, like things like incremental processing, the ability to do work with merge on read tables and intelligently kind of balance all these kind of different workload types when you're writing the data at the same time, and you want to make sure you want to asynchronously compact the data files. So these are the kind of primitives that have allowed Hudi to be more balanced in terms of real-time workloads. And these primitives, they work really well with real-time processing engines like Fling, Apache Fling for that matter. So I think these are really good segue into that world. And all these principles tie up with how indexes work, right? Hudi provides indexes, for example. So these are some really good foundation to look forward and how kind of Hudi enables a real-time workload overall. There is a question from Bharat, who says, does Hudi need a catalog for its functionality? So Hudi by default doesn't need a catalog I think I understand from the point of view of other table format, which requires a table catalog to start with, because that's how they will guarantee the atomic transaction. But Hudi works, like I said, in a timeline-based approach. So you do not need a catalog to start with, or start your exploration of Hudi. But of course, catalog is an important aspect of the overall Lakehouse architecture, and we are seeing it a bit more come up in our architecture now. So I think you would want to basically write your tables as Hudi, and then you would like to sync it to a catalog to make it available to different query engine like Presto, Trino, or any other environment as such. So that's how the catalog part comes into the picture. That is pretty much it. I think we can end this particular session around this, and hopefully we'll see you on the next episode of Lakehouse Chronicles with Apache Hudi. We'll be having this session online over YouTube as well. So feel free to check it out later. Have a good one, everyone. Bye.